Flight Director Gene Kranz to my left. I'll turn it over to Gene at this point.
Okay, we've got, at your request this evening, Tony England over here to talk to you about how we intend to use some of the command and service module lithium hydroxide canisters. We've got Bill Peters, the telemu, who's the man responsible for the electrical and the environmental systems, instrumentation systems of the LM spacecraft. And Dick Thorson, who's responsible for the LM control systems, propulsion, RCS, and certain of the guidance systems. We picked up on shift at about 74 hours and 30 minutes elapsed time. The majority of our work for the first few hours in the shift was associated with modifying the crew checklists for the dock dips burn we performed later at 79 hours and 30 minutes roughly. Now these were lists that we had developed actually for a lunar orbit insertion abort. And as such, the majority of the checklists were available in the control center for a lunar orbit insertion type contingency. And our primary problem in modifying these checklists was to make sure that we used the minimum power to accomplish the desired maneuver, as well as to make sure that we put them in proper sequence so that we didn't have any unnecessarily long power up. At around 75 hours, we got into a relatively long discussion of passive thermal control, and I'll come back to that later on. And as soon as we completed that, we went into a review of the mission rules with the flight crew. Now, we actually had a very short review when we talked to them about some of our guidance and control type rules, the rules we use for attitude and rate deviations. During the period of time we were reading them up their contingency checklist changes. Later on we came through with a relatively detailed checklist update. This took just about 45 minutes to get the checklist information up to the crew. At around 75 hours and 45 minutes, we had provided the spacecraft, the state vector, and the target load for the mid-course correction maneuver we were performing. And we went through a consumable status, and I'll come back to that later again. At 76 hours and about 30 minutes, we went over the rules with the flight crew. Again, we were being very conservative on this particular burn because I think you were aware that if we did not perform the burn, we were on a free return trajectory and would splash down in the Indian Ocean at around 152 hours. So we wanted to set the limits for the crew monitoring of the burn very tight. In other words, we had to have a nominal performing descent propulsion system in order to initiate and continue the burn, and if for some reason the descent engine should start deviating in performance, we wanted to shut down the burn. Now, we were doing this primarily because we could make a small mid-course correction sometime later on in the mission and bring us back to a free return trajectory again. So we played that particular maneuver very conservatively. I believe you've probably got a transcript of the air-to-ground communications at that time, so that I don't think there's any need to go through all of the rules we read up to the crew. Now, one of the items that was of concern to us as we entered the burn was how good was the platform orientation. And we made two checks, one looking at the sun, and the other one, that's using the AOT, and the other one immediately prior to the burn, where we were looking for some kind of a bore sight to make sure we were in the right attitude for the burn. And fortunately we happened to find that the moon was on the commander's LPD. So through these two checks we felt that we had a very good platform alignment, and we had almost insignificant drift on the platform from the time that we originally oriented it just prior to the time we left the command and service module. I'll talk to you briefly. We reviewed at around 77.5 hours. We reviewed the power down checklist, and as you're aware, much discussion ensued in getting this up to the crew later on. But our basic configuration gives us low bit rate telemetry from the spacecraft, S-band voice from the spacecraft. We've got a coolant loop up and operating. We've got suit fans on. We've got a cabin repress capability. We've maintained a RCS manual attitude control capability, and we've got the caution and warning system powered up in the spacecraft. At around 77:56, the S4B impacted. I have the precise time later on here. I'll look for it in the notes, and I believe you probably got that word. At around 78 hours and about 15 minutes, the crew started the powering up of the LM spacecraft for the dock dips burn. The burn was scheduled, and I'll give you the delta V's. The burn was scheduled for 79 hours, 27 minutes, 38 seconds ground elapsed time, and the X component of the burn was 833 foot per second, and the Z component of the burn was 213 foot per second. Effective delta V was somewhere around 900 foot per second. The impact time, as we've got it from the site that was recording the transponder on the S4B, was 77 hours, 56 minutes, 40.025 seconds. We gave the crew their final target load and state vector as they came around from the backside of the moon at 78 hours and 19 minutes. And by this time, the crew was well into their activation checklist, and our electrical power main bus load was running about 40 amps. Previous to this time, we had widened the dead bands on the digital autopilot to conserve some reaction control system propellants. And at about TIG -1 hour, we narrowed down the dead bands and kept the communications up so we could have high bit rate telemetry throughout this entire last hour to make sure that we had a really good spacecraft for the maneuver. After, at this time, we went around the horn and made our decision on the initial LM spacecraft power down, and we advised all the flight controllers that we would start with the power down of the LM spacecraft at around cutoff plus about 15 minutes. We again wanted to make sure we had a good spacecraft post-burn, and we wanted to let the system stable down before we started powering down the systems on board the spacecraft. We gave them a go for the burn at 79 hours and 18 minutes, and at 79:27:40 approximately, we initiated the ullage. The burn looked very good. In fact, it was an excellent burn. Our peak current during the burn was around 50 amps, and the burn terminated roughly at 79:32. Immediately thereafter, we gave the crew their initial power down information to bring the majority of the spacecraft systems down, with the exception of the communications system and the guidance navigation system, because we had to keep that up to initiate the passive thermal control. The crew spent about 45 minutes getting into attitude for the passive thermal control, and about 30 minutes to allow the rates to damp out prior to initiating the roll rate. The tracking and the burn came in at about 81 hours and about 15 to 20 minutes. And the initial cut on the tracking said that we had had a very good burn. Preliminary indications were that we'd perform a mid-course correction 5 at around 104 hours elapsed time, and the delta V would be between 4 and 6 feet per second. It may turn out to be something less than that by the time we get more tracking in this evening. We had a long discussion on the lithium hydroxide canisters, and I believe Tony can fill you in on whatever questions you may have there. We got into the attitude for PTC at about 81 hours, We gave the crew a total briefing on the consumables, and I'll summarize the consumables as they stood at around 81 hours, 24 minutes elapsed time. The electrical system, we had 1,498 amp hours. This means that we must maintain an average load in the spacecraft of less than 24.5 amps. At the present time, we expected to be able to power down to around 14 amps main bus current. We're running somewhere around, I guess, 13. Is that right, Bill? It's running 12 to 13 amps right now, so looks like we'll start making some money in electrical power system throughout the night and throughout the next day. From a standpoint of water, we got 215 pounds usable. Some broken communications. It has not happened yet. It seems we've got a good stable PTC. But if the communication should become broken, we may be able to communicate to them only 50 to 75% of the time. So we gave the crew gross procedures they could use for selecting the antennas for us to allow us to communicate with them much more of the time. And that was about it. We got off shift at around 82 hours and about 30 minutes.
Okay, why don't we open it for questions now? Please hold your hand and wait for the mic. This gentleman over here.
Mr. Kranz, can you tell us two things? There was a report of what may be some new venting. Can you tell us about that? And can you tell us what sort of physical discomfort the crew is in at the moment?
From a standpoint of new venting, we had not been aware of any venting during our shift. As you're aware, we had some problems in establishing our passive thermal control, although we finally established it. It looks good, and we thought the problems, in as much as we were using very low thrust pulses on the RCS system, may have come from the sublimator in the LM spacecraft. So that is the only knowledge I had now. There may have happened something in a subsequent shift. Ooh. When did that occur?
It's about the time you were changing, I think. There was this report that they had seen some new gas, and they were asking them from here whether it was residual from the original thing or whether it was new, whether they thought it was new.
About the majority of the pre-burn type procedures and post-burn type procedures, and I believe Jim Lovell's
That's because he's
man
Haise
seems
is
to
the
be
man
somewhat
that's all
behind.
watched now.
We're trying to work up some kind of a crew rest cycle right now to give them all an adequate amount of rest between now and the possible mid-course correction at 104 hours.
Art Snack.
A couple of questions. How much better off are you on consumables tonight than you thought you might be last night? And secondly, what does a flight plan call for the next 24 hours?
I'll answer your last question first. The flight plan for the next 24 hours is basically going to be passive thermal control, minimum activity, and we're going to stay powered down as long as we possibly can. Let's see, what was the other question you had? I'm sorry.
I was wondering about the consumables and how much better off you are than you thought you'd be tonight.
I think that, at least from my standpoint, I feel we're much better off than we were last night. I thought we'd have to maintain our bus levels at about 14 amps throughout the rest of the mission, but it looks like we have a bit more flexibility, and I think tomorrow we'll have a much better hack on this, because I think the key consumable now at the present time seems to be water. So once we get a hack as to how much water we're going to use in a fully powered down state, then I think we'll be able to give you a good answer. But from my standpoint, it looks a lot better now than it did last night. Although, again, last night we had the capability of coming back. We just got a better margin to work with, more flexibility now.
Carl Abraham.
Could we have a rather detailed explanation of the tests that were run in the simulations with the lithium hydroxide canisters, and a description of how this hose is being attached or will be attached to a canister, and particularly what hose that is, where does it come from, and what's going through it?
That, and he brought you over one of the canisters.
This is our mailbox. As you know, we use the lithium hydroxide to scrub CO2 out of the spacecraft atmosphere. Okay, I'll talk more directly into it. We have a limited amount of lithium hydroxide in the LEM, and it would relieve a lot of the pressure on the environmental control system if we could use some of the canisters, lithium hydroxide canisters from the command module. So actually Jim Corielli over in Crew Support Division who designed this thing, and it does an excellent job. What we do is we use the suit loop in the LEM, and this is the scavenging hose, the exhaust hose, if you will, from the suit. And we just put the lithium hydroxide canister on the end of it, and it's not so easy to fasten on there. We've used a data card out of the flight plan to make a structure so that the plastic cover here won't collapse on the end of the hose. The canister itself is coated with Teflon, and none of our flight tape would stick to it, so he designed sort of a grid system that goes around it that allows us to fasten things to it. And we've had one of these running for about 3 hours over an 11-foot chamber in Crew Systems, and all indications are that it's doing the job. I understand that we have about 16 cartridges in the command module, and each one will have a lifetime of about 12 hours. And we'll be running 2 at a time, one on each of the suit loops in the LEM.
I have a number of questions about the test and also about one condition in the spacecraft. We're correct in assuming that they're still running at 5.5 psi in the spacecraft now, and what was the pressure and the absolute pressure and the partial pressure of carbon dioxide at which you ran the canister tests?
The canister test isn't complete yet, and the last I saw it was just building up. I'm not sure. I think it was 20 millimeters of water pressure that we were going to build up to in the test, and we're not going to allow it to get above 15 in the spacecraft. The test isn't complete yet. It takes several hours.
The other question was, is the cabin atmosphere in the spacecraft now at 5.5?
Yes. Well, that's right.
Bill?
It's closer to
4.7.
Sorry.
4.7, 4.8.
Dr. Kim?
What is the humidity situation and how do you control the humidity?
The LEM has some water separators in the suit loop in the lunar module, and they are working, and they're separating the water and controlling the humidity properly right now. There's no problem with humidity.
Mark Bloom?
Gene, you've always been recognized as the LEM expert. How would you classify the LEM as a spacecraft that can get these men back to Earth? Would you say it's in good shape, and how is your confidence factor compared to, say, last night at this time?
It's interesting, Bill. I forget when we got started. I think back in Apollo 9 we first started looking at the use of the LEM as more or less a lifeboat. And fortunately, although the exact procedures do not tailor the exact case we've got, we had looked at the utilization of the LEM for an awfully long time, so we knew what the limitations were. We developed workaround procedures wherever it was possible. I think the LEM spacecraft's in excellent shape, and I think it's fully capable of getting the crew back. I think, as we have found before, every time we've put the LEM spacecraft to a test, it's always done much more than it was guaranteed to do, and I think this is a good case in point.
What was your confidence factor anywhere near this high last night about this time?
Yeah, it was, let me put it this way. Last night I felt we were going to have a much trickier management problem in our hands. It is not the easiest right now, but I thought that the overall management of all of the energy, the water, all the consumables in the spacecraft were going to be quite difficult. And I think one of the things that was very pleasing to me this morning, or when I got on shift around 12 o'clock, I guess it was that we were still running at relatively high power levels, but our consumables rates had steadied down to slightly less than what we had anticipated, and we were also happy that we were pretty well off in the RCS system. So from that standpoint, I think we have a tricky management problem coming back, but I feel that we've got a good handle on the situation and know how to manage it.
Jack Jones.
You described the crew as reasonably uncomfortable. What's the discomfort besides maybe the tension? Is there some physical?
No, I'd say that the primary discomfort would be from trying to rig up some adequate sleeping capabilities in the LM spacecraft. I have not had the opportunity. Maybe Tony can answer a question on that. I really haven't looked into that in detail because our primary job has been managing the systems and getting ready for this burn. But I believe it would be primarily in getting those guys into a point where they can sleep comfortably in there while somebody's moving around using the communications and making periodic checks in the spacecraft systems.
Well, you don't.
That's right, they could very possibly be.
Okay.
I guess I ought to correct myself.
If they're testing this canister setup, how are they handling this in the spacecraft at this time?
Well, it's not necessary to put this in the circuit until sometime tomorrow. We're going on the secondary canister in the LEM any time now. The CO2 level is getting up near 15. And we'll have, I believe it's 8 hours. Is that right on the secondary?
Yeah, we've got 3 additional.
Comes when crew members awaken in the morning, if I remember right from the flight plan. That's right in the front of your flight plan. I didn't have any crew status reports in my shift, and the doctor did not indicate that they had any problems, so that was basically the status we had when we left.
Paul Racer.
Gene and perhaps Dr. England, I'm sure y'all have gained a picture of possibly of what life is like up there. And I'd kind of like for you to share it with us. There's some confusion about where the astronauts are spending most of their time. Are they all huddled in the LEM? What are they wearing? Are they having to dodge some foods because the salt content would make them crave water? This sort of thing. Any observations like that would be useful.
Well, they seem to be spending one fellow in the command module all the time, 2 in the LEM. The guy in the command module should be sleeping, but these fellows are pretty diligent, and I'm beginning to sense that they're taking a lot of pictures of the moon and the Earth, and they're even doing some studies on some of the particles that are flying off the service module back there. I don't know whether that answers all of your question. I wouldn't describe them as all huddling down in the LEM. They're pretty busy. Yeah.
Paul Racer.
Are they dodging certain foods because this would make them crave water, for instance?
I don't know. I haven't heard anything like that.
Jim.
What garments are they in? Do you know? Are they constant wearers?
Well, they'll be in the constant wear garment with their coverall.
Jim Maloney.
2 unrelated things. One, is there any way for the medics to know what their condition is? That is, if any of them at any time in the biomed harnesses? And the second thing is, has anyone come up with a way of finding out what the cause of this explosion or accident is?
To answer your first question, yes. We're looking at biomed data tonight on, I'm really not sure, I think it's Fred Haise. And what we're interested in there is to just monitor his condition as a function of, I'd say, a backup measurement of any possible CO2 buildup in the spacecraft. Now, we don't expect that, but we are monitoring it. The problem we've got there is that since we are operating in a low bit rate mode with the spacecraft on the Omnis, we do lose some signal margin there. And if this turns out to be a problem later on in the evening, we'll probably switch off the biomed instrumentation, because what it amounts to, it wipes out the rest of our other instrumentation at the power levels we're at. from a standpoint of what's being done to try and determine the cause of the explosion or whatever the problem was that happened in the service module, equipment bay in the area of the cryo tanks and the fuel cells. I really don't know, Jim. It's pretty much tough staying on top of our job without worrying about what happened many hours ago. Now, we are looking pretty deeply into the entire status of the command and service module, and we're trying to come up with, tomorrow, for instance, we expect to read up to the crew more or less a standard configuration we want them to go to for all of the switches, circuit breakers, and everything in the command and service module. We're looking for to see if we can make a test to verify whether the main B bus has any problems associated with it. And then tomorrow afternoon, we're spending a large amount of time looking at such things as reentry checklists, and particularly from a standpoint of establishing a timeline for separation from the service module and subsequently separation from the LM spacecraft prior to coming into our entry interface time. So the primary work we've got going in the command and service module is to make sure we get a good one and do whatever troubleshooting we feel may be necessary, and then to really shake down those procedures.
This gentleman here.
Can you explain this collecting of water they're doing in the plastic bags, where they're getting it or what they're going to do with it? Or
Potable. Yeah, I believe that's, they're collecting the water for their drinking and food purposes from the service module potable tank, and they're just using their normal procedures. Remember, they used to have this technique they use for separation of the H2 that may be in the tanks from the water. So it's just normal water collection procedures in the service module, or in the command module.
Okay, let's take Carl Abraham and then two more questions. We're going to have to break it and let these gentlemen get some sleep.
We were told before the burn that two people would be in the LEM and one would be in the command module. And later on I got a part of a quote which seems to indicate that maybe that wasn't the case. This quote was, "He's the only CMP that's ever witnessed a dips burn sitting on the ASCENT engine can," which would lead one to believe that all three of them were in the LEM at the time of the burn.
Yeah, this is a interesting item. Yeah, all three crew members were in the LEM at the time of the burn, and we had computed our dips gimbal trim position for the man in the command and service module spacecraft, which caused a center of gravity movement that caused the engine gimbals to compensate for the fact he was in there. So we saw that excursion, and then once we found out that, yeah, we had a CMP in the LEM spacecraft, we knew why the excursion.
Okay, let's take Art Schneider. Oh, yeah, follow it up with one, Carl.
Would you care to speculate why all three of them got together in the LEM at that time?
I think the third man wanted to see what was going on.
Art Schneider and then John Harris, and we'll close it.
In the discussion of food about mealtime, was there some fear of contamination of some of the food in the command module?
Not to my knowledge. I didn't hear any. Tony, did you? Or Bill or Dick?
They were trying to find something that would use less water. I mean,
Is that right?
that's all.
Now, at the time they were going into mealtime, we, as you were aware, were having some problems in establishing our passive thermal control, and that became an end in itself for about a half-hour period there. And generally during that periods of time, we hand over either to the assistant, generally to the assistant flight director, to be following the normal course of the mission.
Okay, let's close it with John Harris.
What single factor, if any, is giving you the most concern at this time?
Gee, it's probably one that I'd say the one thing, if anything, is bothering me is a large amount of checklist changes we're making. That's why we're always trying to stay several days ahead of them and verify them in the simulators, because once you've got tried and true procedures, you like to stay with them. And I think we've gone through the major portion of the checklist changes now, so I think we're pretty much over the hump from that standpoint. It's always nice to be operating in a mode where where you're actually using procedures you've used before, and that's a good way to be.
Checklist. By checklist, you mean re-entry checklist? Does that mean the re-entry is giving you concern?
No. I'm saying all the checklist changes we had made up to date. From a standpoint of discomfort, that was about the major item, because I think we felt we had a good handle on how to manage the systems now and how to go about making this burn. We had made long dock dips burns, for instance, back in the Apollo 9 mission. So we were pretty confident of those procedures.
Thank you very much, gentlemen.